Good afternoon, everybody. My name is Adrian Ford. I'm a program manager on the Windows 7 team at Microsoft. I'd like to welcome you to this session. It's PC 15, and I'm going to be talking in this session about the work we've been doing in Windows 7, the investments we've made around enabling applications to benefit from the high-quality, high-performance print path that we have, and also the convergence that's happening between printing and electronic paper documents. I'd also like to congratulate you on being here in your last session at PDC. If your week's been anything like my week, you probably deserve to give yourselves a round of applause right now just for being here at the end of the day. So well done, everybody. Thank you for coming. Okay, so just to start off with, I thought I'd give you an overview of what I'm going to cover in the next hour or so. If I'm on time and I remember my stuff, I'll leave plenty of time at the end for questions, so you can come and quiz me. First of all, I'm going to start off at a very high level, and I'm going to talk about the big trends that we see in the industry, the things that have been happening, the convergence that we see around printing and electronic paper. And then I'm going to talk about the investments we've made in Windows 7, and then I'm going to go right down low and talk about the API surface we have, show you some code. I'm a program manager, so we'll get lost in the code. Any bugs there will be my bugs, not the code bugs. And everything you see today is running on M3 6801 build. So the build you have in the goods is the stuff that we're using today. Why this is important, or why we think this is important, if you're developing applications that need to print from the new D2D and D-Write, Direct Write and Direct 2D APIs that we announced this week that are in Windows 7, XPS and the API surface that we'll talk about today provide you a print path from those surfaces. Also, if you're working on applications that require very rich printing support, so if you're looking at wide gamut, high dynamic range, high precision color photography, if you're looking at advanced graphics, transparency, those kinds of things in your application, there's now a way to get those through down into the print path. The next two areas we're going to touch on is the emerging trend for very intelligent document peripherals and how you can take your applications and integrate with those, which is becoming very important for our corporate customers, our mutual customers in corporate and enterprise. And then lastly, how you can integrate into electronic paper workflows, again, very important for our corporate customers. Hey, I found the button. Okay, so to start off with, I'm going to talk about the big trends that we see. And the first one here is around rich content. And hopefully everyone's familiar with what we mean by rich content, that basically it's more than 8-bit RGB color, it's smooth gradients, it's transparency, it's advanced topography and advanced graphics. And we're seeing that increasingly in a number of areas. Microsoft has made a number of investments over the last 2 or 3 years. For end users, you can see Office 2007 uses a lot of this kind of stuff. In the platform, you can see that with things like Silverlight and WPF, and now with Direct 2D and Direct Write, we're making it available in our platforms. And developer tools, things like Expression, is helping developers generate applications that take advantage of the capabilities of the platform to generate this rich content. So we're seeing a lot of this kind of stuff, and our mutual customers, our end users, expect that you can print this, expect you can archive it, expect that you can store it in some way. The next trend that we're seeing is this trend around document workflows. And here, if I'm thinking particularly about the back end of the document lifecycle. So if you think about a typical document lifecycle, we start off generating content, rich editing, applications like Word, for example, rich review cycles. But there comes a time when that document is finished and complete, and you want to go and publish it, share it, archive it. And for that end of the document lifecycle, increasingly we're seeing the need for what we call fixed layout formats, electronic paper formats. When we talk to our enterprise customers in this area, we get a lot of feedback on particularly 3 issues that they see that they're looking for solutions for. The first one is the fact that our PCs have not resulted in the paperless office. If you look around, they haven't replaced paper. They have replaced filing cabinets, which drives a need for having the ability to store things electronically and retrieve them very efficiently. The second trend that we see, or problem that our customers see, is one around cost within the enterprise. When we talk to IT departments, something around 10% of IT budgets is spent on print and print-related costs. Financially, that's very expensive. Environmentally, that represents a very big cost as well. And there's a number of reasons why our customers want to reduce that and take unnecessary printing and move that into some virtual domain. And the third area where people see problems is one around unstructured documents in the enterprise. With increasing regulation, concerns about governmental compliance, risk management, those kinds of things, they're looking for a way to move that unstructured data into structured systems and for a common format that is reliable, safe, and secure to put that in. And then the third trend I wanted to talk about was this one that we see around intelligent devices. Traditionally, after the mouse, the keyboard, and the screen, printers have always been the most connected device to our PCs. Increasingly now they're moving off onto the network. We're seeing those being network connected and becoming much more intelligent. So they want to participate in workflows across the network as first-class citizens and not as some second-class citizen that's attached to a PC. In order to do that, we need a great way to communicate electronic paper to those devices and to receive electronic paper back from those devices. So the on-ramp and off-ramp, if you like, that bridges between the electronic and the digital worlds. So when we look at these things, we see that they're pretty much connected. And we did a lot of work back in between 2004, 2006 to come up with a way that all these different trends could be connected. And we've done this with a format that we developed with industry, which is called XPS. And this format allows us to take the very rich content that applications and customers are generating and send that down to our devices that are capable of reproducing it. It allows us to put that into workflows as electronic paper. It also allows those devices to participate in workflows as first-class citizens. And if we look back to 2006 in the Windows Vista timeframe, we built out support for this stack in a number of areas. So we put support for this for customers in Office 2007. We did work within Windows SharePoint so that document libraries can understand these electronic paper files and act upon them. We did a developer surface in .NET 3, which is in .NET 3 and later. And, of course, we did some work in Windows to provide support for that within the print subsystem. Okay, so that's some background context. I just wanted to drill in and take a look at this thing, XPS, and just give you a quick overview of what the format is. For those of you that aren't familiar with this, XPS is an acronym for XML Paper Specification. As you might guess, XML means that we use XML extensively within the format, both in the packaging layer, which is the way that we construct the file itself, and in the markup that we use to represent page content. The design intent for XPS is for it very accurately to represent the printed page. So if you can represent something on paper, if you can scan it in, or if you can print it out, then we designed XPS to do that and just that. And the just that is quite important. As I mentioned previously, we're targeting this at that second half of the document lifecycle where you're sharing, archiving, and publishing content. And for it to be successful in that space, it needs to have a number of characteristics. For example, the content mustn't change. If I'm going to share a document with lots of people, I want to be confident that the layout won't change, the content on the page won't change. And to that end, we have a number of features, or we like to call them non-features. There's things that we specifically don't support in the format so that we guarantee that things don't change. So as an example, there's no support for programmatic control. There's no support for document automation. We can guarantee that every viewer and every device that interprets this always shows the same content. Another feature of this, particularly important if we're communicating between different devices, many of which are not Windows-based devices, is to ensure that the resources that you need to render the content are always within the document. So you cannot create an XPS document that doesn't have the fonts in there that you need, the image resources in there that you need, or the color profiles that you need. So everything's contained within the document itself. One of the big things that we've seen over the last few years is operating systems have got smarter about being more secure. And as collectively the industry's done a good job about making their operating systems more secure, we've seen the bad guys go and look for other ubiquitous attack vectors. They're looking for other pieces of software that are widely deployed across the enterprise or across customers. And so one of the things that we were very careful about when we designed XPS was two things. Firstly, that the format itself is secure so that we don't have things like programmatic code. And that's very important because XPS, as well as a person-to-person format, is a device-to-device and person-to-device format. So it's designed to enable lots of machine-to-machine communications where we don't have people in the loop to click a UAC prompt or something like that. Other thing that's very important about XPS is we designed it so that implementations were relatively simple to do. So the common foundations are zip and XML and standard image file formats. And that makes it easy for third parties to make secure implementations relatively quickly and easily. The other point that's quite important about this is this isn't just a Microsoft thing. We designed it with industry. We had a lot of industry input before we published version 1 in about this time 2 years ago. We worked very hard to make it so that anyone could implement it on any platform. Right now, there's a number of implementations on everything from Mac to Linux to VxWorks to embedded platforms. And at the moment, it's available as a download from Microsoft with a community promise that enables open source compatible implementations. In addition to that, we're doing a lot of work with partners in industry, a few of which I can see here, who are working with us to go standardize this. So basically, it's a format that the industry owns rather than any one particular vendor. Okay, so that was kind of like a quick look at XPS and kind of like the trends and things that go behind why we developed XPS. One of the things that I just wanted to show you real quickly is a quick demo just to give you a feel about what this looks like. Is anyone here familiar with XAML? There's a few hands up. That's good. Okay, so I don't have prizes, but keep your eyes open. So this is just an XPS file. It says hi. It's the last session. Should really say bye. Never mind. Best laid plans and all that. And what I'm going to do is I'm just going to make a copy of this file. So I just did a quick copy on the desktop. And now I'm going to go in and I'm going to rename it as a zip file. And yes, please, I do want to rename it. And now I'm just going to use the shell just to extract this. Hopefully you can follow along what I'm doing. I'm just going to extract this into a folder. So I'm unzipping my XPS file. And in here I have a number of resources. And the actual model of XPS uses a container layer that has files and folders that are mapped to these low-level parts. And this is very highly structured. There's actually an ISO standard that defines this. It's called OPC. I'll talk about it briefly, but I'm not going to get into the details. Find me afterwards if you're interested. But it's a very structured way of reliably putting content into a file. And to give you an idea behind that, what I'm going to just do is just show you what's in some of these things. So here I have a contents types file. And this is a way where I can actually define exactly the content type of everything within this container. So for example, I have a file here, which is a JPEG. The image in this is a JPEG. It's not sufficient just to tell me it's .jpg extension. I actually want to go and validate that it is a JPEG file against the content type that's defined here. So what I'm going to do is I'm just going to drill down within this package, and I'm going to go and have a look at my documents folder. And this has one document. And, whoops, didn't want to do that. And within here, I'm going to go and grab, it's a one-page document. And I'm just going to grab, this is the markup for that first page that we saw. So if you remember what that looked like, it was just a, in fact, perhaps I should show it to you. So just to remind you, it's basically an image with a transparent rectangle laid on top and just some text within that transparent rectangle. Very simple. So if I just go back to this, we can see here I'm just setting up a fixed page with some page dimensions. I've got a canvas, which is a grouping object. Those of you that have done work with XAML and WPF probably think this looks very familiar, and there's a good reason for that. Here I'm drawing my path, and I'm filling that with my image brush here. And you can see in this line here that my image source is a URI that links into my package into this resources folder. And I mentioned that resources are always included, so let's go have a look in the resources folder under images. And there's that image that I had within the document. Likewise, if I go down here, I've got a second path. And the interesting thing just to note here is the fill from this path is defined with a transparent color. So that 99 at the beginning of the sRGB color definition is the transparency to apply for that particular fill that I'm using within that path. And then down here, I've got my glyphs, which is my text. I'll talk more about that later. And this is where my string comes from, by PDC. Now, we did say that we should change it to by PDC, didn't we? So I'm just going to go in there and change that. We'll save that file. We'll close this down. And because that's a zip file that I'm in, oops, I can just go back to that root of all the documents. I'm going to select them all, including my change that I just made. And I'm going to go and I'm going to ask the shell to make me a zip file again. And I'll rename it as XPS because it is an XPS file. Oh. Hey. What did I do wrong? Let's try that again. All the best demos fail first time. If that's the only failure that we get today, I'll be very happy. Okay, there we are. So I zip that up, and that's got the new text that I put in within that markup. So goodbye. Okay, now we do have a bit more. So that was kind of like a very quick look inside an XPS file, just breaking it up in the shell, showing you it's a zip file, getting in and playing with the markup, and so on. And just to give you a feel for some of the stuff that I very quickly went through here, this is kind of like the document structure that we have within inside that zip archive. And at the top of the diagram, I've got a number of things that are in this OPC layer. So OPC is a standard that you can use to package lots of different resources into a single file. You can use it for anything. Microsoft uses it for the new Office 2007 formats. We use it for XPS. We're using it for other things. People like Autodesk now use it for their DWF format. It's a very robust way of building very structured, discoverable proprietary file formats. And at that low PC layer, we give you support for some fundamental things like signatures, thumbnails, metadata and properties, and things like that. And then on top of that foundation, we build our XPS domain-specific content. So this is the fixed layout document electronic paper format that we have. And this basically consists of a number of documents in a sequence, typically only one. And then within that fixed document, we have a number of fixed pages. And those pages have markup and reference to resources like images, fonts, and so on. So that kind of just gives you the diagram that shows what was inside that zip file when I exploded it. Okay, so most of what I talked about so far has been history, and history for us anyway. And what I want to do is really focus on what's new in Windows 7 and the investments that we've made in Windows 7. So, first of all, we've built out a complete Win32 native API to support everything that we're doing with XPS. Previously, in Windows Vista and .NET 3, we had a really good story for managed code developers that were moving into WPF. We didn't have a story at all if you were Win32. So we've done a lot of work to open up the investments we've made deeper down in the stack and in the ecosystem for those of you that are working with Win32. That API investment pretty much falls into three categories. We have support for XPS, and that's what I'm going to focus on most today. We also have complete support for OPC, that packaging layer, so you can do custom file formats. And then we have a print API. So if you want to interface with the print subsystem using this, we have a great way to get in there. We also have some other things that I'm not going to talk about today in Windows 7, an improved user experience for XPS, which you'll get a glimpse at as we go through the demo probably. And then some investments for our hardware partners that we'll be talking about next week at WinHeck. So just to put this in context, this is what the world looked like last week, I guess, before our keynote. At the top of this, I've got the XPS, which is indicating kind of like the XPS ecosystem. So that big ecosystem I showed you at the slide at the beginning with all that rich content and devices and workflows and everything else. And in Windows Vista, we had the XPS print path that was there, which you could send things to if you knew how to get into that print path. But as far as an API platform, we only really had support for development against .NET 3. And there we have great support from WPF for XPS OPC for printing. We can serialize to and from WPF visual trees, which is a really nice way for generating dynamic content, for example, through into XPS. But if you're a Win32-based developer and you came to us and said, this is great, I've got this page layout application, I really, really want to take advantage of this print path, how can you help me? We gave you a 450-page spec. And then you said, hey, but you guys are platform guys, can't you help me more than that? And we said, yeah, here's the documentation for MS-XML. Go write out your markup, which wasn't really what they were expecting. But some of them thought that was a great idea, and then just as they were leaving, we did our one more thing for them. And we pointed out that if you were developing on Win32 and you built out support yourself for the XPS print path, you still had to maintain your GDI print code. Because if a customer came along and plugged in a legacy GDI printer, we gave you no support to go convert for that. You could use the support for that was in .NET, but that means taking a dependency on .NET, and that's not a good reason to take a dependency on .NET. There's many good reasons to use .NET, and that wasn't particularly one of them. So hopefully you can guess why I left that big space in the diagram, because we've filled that out in Windows 7. So now we have Win32 APIs for XPS, for OPC, and for the print API as well. So you can go and build on top of that infrastructure and the ecosystem behind that infrastructure that we have. And that's really where I'm going to focus the rest of the talk, is just walking through those APIs and giving you a view of what's behind those. Okay, so in true Adrian style, I'm going to do a demo that's creating nothing. And there's a good reason for that, hopefully. Okay, so this is some sample code that I'm going to walk through and just use to demonstrate a lot of this stuff that we've been doing. One of the things I just wanted to call out in this is very similar to the sample code that's in the hands-on lab. There's a DirectX hands-on lab. Part of that is concentrating on XPS and printing. So the code you see here is a simplified version of that lab, because we kind of like build you up to XPS in the DirectX lab. So I took that and trimmed it down to this. The other thing just to point out is I've got this little macro that you'll see around. If fail, then clean up. You can just ignore that. That's just, as I think Leo said yesterday in his talk, poor man's exception handling. So I'm just in this simple application. I'm just defining some stuff at the front here, my page size, which is letter. And I'm just going to, the interface is exposed through COM. So I've got a couple of co-create instance calls behind here, just to set up a factory for my OPC layer and my XPS layer. And you'll see why I need those two things in a minute. And then the first thing I do here is I create a package. So that's basically an empty zip file, which is my package that I'm going to go and put some stuff into. And then, if you remember that diagram, I have a fixed document sequence and a fixed document that I want to put in that package, which is my framework structure. And what I'm doing here is I'm creating the URIs. Every part within an OPC file is addressed via a URI. And this is just a way of making sure that everything can be found easily. You follow those references around. We recommend a naming convention that people can follow. But because this is a low-level API, we actually let you specify your own. So you can go and do things like put custom content within the same container and not get namespace collisions. So once I've set up those URIs, the next thing I'm going to do here is just go through and I'm going to create my document sequence here. I'm going to create my document here. And this is where I go and add that document to my document sequence, add that document sequence to the package route, and then I ask it to get me all the pages that are in this document. And at this point, any guesses? Yep, there's no pages because I've not created any pages. It's just completely empty. So in this little fragment of code here, I'm just going to do the same thing. I'm just going to create a URI for my page, and I'm going to add that to the list of pages, and then go ahead and append that to the end of my collection of pages in the document. And once I've done that, I'm going to say to the package, go ahead and just write this out to a very interestingly named XPS file. So I'm going to go ahead and run this guy. And then if I go look in my debug folder, which isn't that one, it's this one, I've got this file here, which is blank XPS. It's just a blank piece of paper. There's nothing in it. That's my empty document. I don't get applause for an empty document. Oh, dear. OK, so that was kind of like a real quick look at the API. Now, the real meat of this is getting into how do I generate rich content? How do I get rich content in there? And I'm just going to give you a really quick overview of what I'm going to go do next, which is I'm going to go add markup to this document. So the markup that we use in XPS is a subset of XAML. It's a very small delta from the XAML markup that you see in Silverlight. It consists of this basic group of elements. Canvas is a grouping element, glyphs for text. You draw things with paths, and you then stroke those paths and fill those paths with brushes. The interesting stuff really is down the bottom. We support a very extended color model with full support for transparency and extended color support, including N-color, CMYK, and every color that we have in XPS is profiled. So there's no such thing as a device-dependent color that's ambiguous in an XPS file. The other thing to note is if you're looking, if you were at the Direct2D and DirectWrite presentations yesterday, you'll probably see there's a lot of similarity between the APIs. That's because we've designed this API for the XPS stack so that you can easily use it with D2D content and with DirectWrite. If I remember, I'll call those bits out as we step through. If I don't, I'm sure somebody will remind me if they see one. Okay, so what I'm going to do now is I've gone back to my sample, and I'm just going to go through a scenario of adding content to my document. So before I forget, I'm going to change this file name, because it's not going to be blank anymore. And so the first thing I've got is a little helper function here that's going to just write some page content to it. I'm going to give that the XPS object factory and my OPC factory, and then I'm going to tell it that I want it to go and draw stuff on this guy here, the page, and that's the same page that I just added to my page collection. So that page collection is in the OM, and I'm going to go add some content to it. So let's dive down into here and see what I've got in my little helper function for writing this page content. So I'll talk about viewbox and viewport in a minute. If I forget, please somebody shout. All I'm doing here is setting up some colors. So these first two things are pretty similar to what you'd expect with GDI. They're sRGB color definitions. What I'm going to do here, actually there's one thing that's interesting here. Here my blue color is transparent. So I'm setting up a transparent blue color here by specifying that alpha value. And what I'm going to do here is going to go and define a green color. And the interesting thing about this is I'm not going to use sRGB, I'm going to use sCRGB. So sCRGB is an extended color space. It lets us represent colors that are outside the visual locus, and it lets us specify colors in all sorts of different precisions. So we use it a lot for high dynamic range and for high precision color. And you'll see how I specify that in a second. I'm just going to give it a value, sCRGB value of alpha, and you'll notice that I'm specifying that as a float because it's an sCRGB color space. So I can give it some red, we'll give it some green, we'll give it some blue, and because I said it's green, I really ought to make it green like that. The other thing just to call out here is that the color support that we have with XPS works very well with the Windows color system from Vista and now in Windows 7. So in terms of color management and converting between colors, there's good interop between those different API surfaces. So the next thing I'm doing here is I'm asking my factory here, the XPS factory, to give me a canvas, which is my grouping element, and then I'm appending that onto my page and adding that canvas onto the end of the visuals that are defined in that page. That just adds that canvas as a root element. And here I've got a little function that's going to draw me just a simple rectangle. So I'm passing in a couple of values that I'm going to use for the width of my stroke, for the colors I'm going to use, X, Y, width and height, and a line join style. And so if we just dive down into this guy and just show you what this helper function is doing. So the first thing that I'm going to do is going to create a couple of brushes. So I'm going to ask my factory, if I can type, to create a solid color brush. And the input for that is going to be the fill color that I specified coming in. Now, because I know that these are sRGB and sCRGB colors coming in, I don't have to specify the ICC profile that I'm going to use to contextualize this color definition, so I pass a null in there. But if I was using CMYK, for example, or a different RGB color space, I'd use a profile for that. And this was my fill color, so it's my solid fill brush. So there I've just defined a brush using one of the colors that I passed into this helper method. And I'm now going to do the same thing for stroke color, and let's make sure that the stroke color brush is there. Okay, so I've created a couple of brushes. And then again, if you're familiar with WPF, this next bit should look fairly familiar. Basically, what I'm going to do now is I'm going to create a geometry. So here I'm creating a geometry, and to do that, I'm specifying 3 line segments, and this is the segment data for those 3 lines because it's a rect. And then when I create the geometry figure, I go here and set it as being closed and filled so that I get my 4th segment automatically for me. And you can generate these collections of geometry figures. So you can have lines and Beziers and other bits to construct your path that you're going to use within your geometry. So once I've done that, I come down here, and this is where I create my rectangle. So I create a path, I set the thickness, I set the line join style, I then set the brush that I want to use for stroking and filling, and then the geometry that I want to do. So that's actually giving me a stroked and filled path, but it isn't actually yet attached to the OM that I've got. So the next thing I want to do is take that canvas that we created up at the top, and from that I can get all the visuals that are on that canvas. There we go. And then onto those canvas visuals that I've got, I'm going to append, which will add to the end of those, the path that I have just generated. So I've added that on, and we're going to give this guy a go and set him off running. And then if I go back to my thing, where am I? Here I should have my not blank thing, and you can just see there in the preview at the side, I've just done a very simple rectangle. That's probably easier to see, with that stroke and fill. Okay, so that's kind of like adding some content to, some vector content to the page. Next thing I'm going to do here is I'm just going to write something. And I'm going to just cheat quickly for this, and I'm going to grab some code so that you don't have the pain of watching me type slowly all of this. So what I'm going to do here is I'm going to use this shell function to create a stream based on a font file that I have on my system. And once I've got that stream, I now need to create a font resource, because, as I said, all fonts are always included. And to do that, I need a URI, which defines where I'm going to store this font resource. And then once I've done that, I ask the XPS factory to create that resource. And there's a couple of interesting things in here. The first thing I do is give it my font stream. The next thing I'm doing here is I'm setting a flag to indicate font embedding. Now, normally we'd subset fonts, so you only get the glyphs of the font that you actually use in the document, so we keep the size down. For this demo, I'm not doing that, because then I can go in and edit the markup and show you changes without upsetting things. And then another thing that we do here typically is we use this word that I can never pronounce, so I apologize. It's a font obfuscation. So by obfuscating the fonts, we stop people taking a document, unzipping it, and then taking that font and dropping it into their system folder and using it as a regular font. And that enables you to honor the font licensing flags that font foundries put in their fonts when you're creating XPS documents. And so down here, I then are going to use another little helper function here. Having got my text resource, I'm going to go and draw some text. I guess that really should be, yeah. And this is just taking my font resource, font size, the colors, and the coordinates to go draw things. One thing I forgot to point out, actually, is the coordinates we use are device-independent coordinates. They correspond to 1/96th of an inch. So if you're running at 96 dpi, then one of those equals a pixel. If you're not, then they don't. So this is where I'm going to go and draw my text. So here I've just got some code where, again, we saw this before. I create a brush for my text. Here I create my glyphs from the factory based on the font that I've specified. Here's I set the origin, the size, and the brush that I want to use. I'll talk about glyphs name a bit later. And then once I've done that, I need to actually set the text that I want to use for this document. Now, one of the interesting things about what we do with XPS is we actually specify the glyph indices that you want from the font rather than the Unicode strings, because there's not always a one-to-one mapping between what you want from the font, the glyph that you want, and Unicode. A very simple example is the FI ligature. That's 2 Unicode characters, but only 1 glyph from the font. So that's quite a lot of messing around that you have to do when you're creating content. We try to make it a bit easier for you. So I can take my glyphs element and ask it for the glyphs editor. And the glyphs editor is this great thing where I can ask it to go and set up a number of things for me. So I'm just going to use it today just to set my Unicode string to do the glyph mapping, but it supports, for example, specific setting of indices and BIDI and those kinds of things. But for now, we're just going to use the Unicode string, which I pass into the function. And then when I finish doing that, I go ahead and I apply the edits to tell it that I'm done setting up the particular glyph run that I want to go draw, and I can go off now and make that text and put it into the OM. And then down here, I'm just doing the same thing again. I'm getting all my visuals from the canvas, and at the end, I'm appending this glyph run. So if we did that right, if we go back and have a look at our file down here, There we are. I've now got my text that I've put in there on top of that transparent bluish color box. By the way, I'm colorblind, so if these colors aren't green and blue, I do apologize. Okay, so we've added some vector content. We've added some text content. The next thing I'm going to do here is I'm just going to go and show how we can add some image content. Okay, so to do this, I'm just going to grab, from here, I'm going to ask the shell again to go and get me a HD photo local resource. I'm doing this from a local resource just because it's easier for you to see what's going on. Typically, you'd use WIC to do this, so that you could query for dimensions of the image, the resolution, all those kinds of things. WIC is a very secure and robust codec framework that you can use. Go look at the hands-on lab. There's examples of how to use WIC in this context in the hands-on lab. And what I'm doing here is I'm creating my image resource from that stream. And then once I've done that, here I'm creating an image brush. And that view box and viewport coordinates that I talked about, they define the region of the image that I want to take and how I'm going to map that into my destination region. So that effectively allows me to crop and scale image content into my destination surface. So that's given me a brush, but one of the problems I've got is I wrote this helper function to take colors and then define the brush. So now I need to figure out a way of how I'm going to draw this thing. So what I'm drawing here is a rectangle on the screen that's black and goes from 0, 0 to the width and height of the page. And if I just run this thing, we'll see that... I closed my window. Never close the window. Rule number 2. You'll see that I've got just this black thing that I've put over the whole of the page. So what I'm going to do now is I'm going to go in and I'm going to modify that. So I'm going to go and ask my canvas to give me its... to get the visuals. So this will return to me that tree of visuals that are on the canvas. I'm then going to ask that list of visuals to get me a specific indice from that tree. I know it's 2 because I added the rectangle, which was 0, then the text, which was 1, then that black box, which was number 2, and give that to me as a visual. And then I'm going to take that visual, and I'm going to get from that the path for that visual. And then once I've got that path, I'm going to go ahead. If it's for me, I'm not here. And what am I going to do with the path? I'm going to set the fill brush for this path and set that to the image brush. So if I go ahead and run this guy again, oh, what did I do wrong? Oh, I know what I did wrong. You can see here I've put that image right over the top, and I've used that. I've modified the path, used that image brush. Because the order that I add things to the OM is the painting order that they get drawn, I've obscured everything that's behind that. Just to prove that's the case, we can go in and we can show you some transparency. I'll set the opacity to that, and then we can just go through. And that's that same thing, looking through, and that's that image transparent over the top of my content. That's really not the effect that I wanted because the image looks really washed out, and hopefully you're sitting there thinking that's not very impressive. So I'm going to go change this a bit. So I'm going to get rid of that opacity because I don't really want that opaque, and I'm going to instead go back into my code here for adding the simple rect. And if you remember this thing, once I generated my rectangle, I was then appending it to the end of my visual stack. So it's always going at the end of my object model. So here I can go in and just, rather than appending, I'm going to assert at 0. So rather than putting these on the end of the stack, I'm pushing them in at the top of the stack, effectively. Those PostScript programmers here are probably thinking this sounds familiar, but don't normally talk about it in those terms. And then if I just go back down to where I was, because I'm now putting that in at the beginning of the stack rather than at the end, then my get at that I'm grabbing from, I want to get from 0. And the other thing I'm going to do is going to make the blue box a little bit more transparent because okay, so now if I did that right, I've got the image that I expected to get with that transparent box over the top with my path round and some text. Okay, so what I showed you there was just going through, and we did rich content. So we did advanced type, we did transparency, we did vector graphics, and we took what I didn't tell you was a 16-bit sRGB HD photo and whacked that into the background as well. And it's a fairly straightforward API to go use. So the next thing I'm just going to talk about a bit, having done that, is how we can bridge between the physical paper and the electronic paper. So you can use that API surface to make very rich content. And I'm going to drill in and just talk about how you can use the print API to go and output this to the print path. Just one thing to note, though, before I go into that. Going the other way, bringing XPS or bringing physical paper into your system through XPS, you can use an API, WIA, Windows Imaging Acquisition 2.0. I'm not going to talk about that today, but that's there in the box. You can use that to bring stuff into your applications as XPS content. And there's a number of vendors that are supporting that in their devices. But going out the other way, I'm going to look at the print path. Now, I've learned during my career that doing printing demos at these kinds of things isn't the most exciting thing, because you just get a piece of paper, and everyone says, wow, it prints. So I'm not going to demo this API. Again, it's in the hands-on lab. You can go drill into this. But I'm just going to walk through kind of like the core function for this, which is start XPS print job. So what we have here is the main function that you're going to call to submit content down into the printing subsystem. First of all, is the printer name, which is kind of like the name of the print queue. That's pretty obvious. Then there's kind of like a friendly name that you can use to refer to that. That gets exposed through the UI to users and downstream. And there's the option with the printer port to go and override that destination. The next two parameters we have here are the progress and completion events. They give you information about job failures, progress of pages, progress of the whole job. And then the next two give the ability to specify a page range. So if you've got a 1,000-page job and there's only 100 pages that you want to print or process, you can specify those in the array. Underneath, the API goes through, grabs the page content. Because everything's highly structured, we can identify the resources that are used on those pages, even if they're shared amongst multiple pages. So we strip that down just to the subset that's needed, which allows for much more efficient downstream processing, better network bandwidth utilization, and things like that. And then we give you back a handle to the print job, which is useful for other APIs within the interface to go and query against. But the next two things are kind of like the important two. The document stream is your XPS content stream. So this is the page content that you want to go and submit down into the print system. You can get that stream from a file on disk if you've got a file on disk. But you can also ask the OEM to serialize that from memory for you, so you don't have the write-read hit of going back to the drive. And that final parameter is the print ticket stream. I'm not going to talk much about print ticket, but it's like the twin of XPS. So XPS enables you to specify the content on the page. Print ticket enables you to communicate with the device in a generic way about capabilities and configuration. So, for example, duplexing is an example. That's how you tell the device to go duplex. It solves a number of problems about how you can take rich capabilities of devices and expose them in a very rich way in your application UI, much richer than you can with the common print dialog. An example of that is Photo Print Gallery in Windows Vista and Windows 7. If you install that and print the photo print wizard that you get, dynamically changes the UI of that wizard based on the capabilities of the print device that you have plugged into it. So that's what you can use. That's the way that you could specify content going down into the print subsystem. And in Windows 7, there's really three ways that you use this. The first, the obvious way, is you use it for printing. This is how you get your rich content down to devices that can support rich content, that have support for the XPS format. Second thing that's really important is if you've got customers that are still using non-XPS printers, this is the way that, as well, you can print to those. So we now have a single combined print path. You don't have to keep GDI print code or other print code around if you're moving to XPS to take advantage of those capabilities. We do an intelligent conversion in the print subsystem based on the capabilities of the device that you're printing to. And the third thing that we're seeing increasingly is many people are using virtual printers as entry points for workflows. So one example of that is print to OneNote that you get if you're a OneNote user. But much more, we're seeing people use that as print to SharePoint or print to Documentum or those kinds of things. And that's really significant because this API can give you a single entry point to that. It completely abstracts your application from those kinds of workflows. But by using XPS, you get the rich content and the stuff I'm going to talk about next, which is the ability to add other features to the document that are useful in those workflows. So as the application vendor, you don't have to worry about what you're being plugged into. You can benefit whether or not your customers are archiving you off into a vault so that they can get compliance certification, or putting your output onto physical paper to send it off to a warehouse. So that's where I'm going to concentrate the remaining few minutes of the talk on, is this area around going beyond just the static content of the paper. Excuse me. So there's a number of features here that we support above and around XPS. Things like support for metadata, so you can describe things about the format itself. The ability to apply digital signatures, the ability to add hyperlinks so that you can make it very easy for people to navigate within their document. If anyone here has used, for example, Word 2007 to save as XPS, you'll see that the heading structure of your document can be reflected in a hyperlink structure in the XPS file automatically, and you don't have to do anything extra as a user to get that. We also support protection by integration with Windows Rights Management Services. So if you have a SharePoint protected document library using Windows RMS, and, for example, you set your scanner up to scan XPS into that repository, then we apply those same rights to the XPS file. So if somebody has the right to view that document but not print it, that right is retained when they take that document and put it on a USB thumb drive and go somewhere else, because we encapsulate those rights around the XPS document. We also have some support for some things like efficient interleaving, which is great for printing when the device you're going to might not have the ability to consume all the content in one go. So what I was going to concentrate is just 3 of these areas. And again, I'm going to go back to the Windows 7 API and just show you how you can go and add metadata to documents very simply, how you can use the signature APIs to sign and authenticate documents, and then how you can use some of the named content structure to go and do some programmatic stuff around documents. Okay, so I'm going to switch back to my little sample app. And so just to quickly set the context. Oh, no, I'm not. That's better. So I'm going to switch back to the sample app. So this is just the same app that we had before that's outputting that little page that we had. And the first thing I'm going to do is just going to apply some metadata to this. And to apply the metadata, I need to give it my XPS object factory, my OPC factory, and I need to give it the actual package that I want to write the metadata to. So if you remember when I showed you that diagram at the beginning, metadata is applied at the package level. And if we just go in and see what this thing's doing. First of all, I'm creating a metadata part here. And here I'm asking the XPS object factory to create me a core properties part. And now I've got that core properties part, I can go ahead and set some metadata on it. So let's go ahead and set the who created this document. Have we got any Channel 9 fans in the audience? Nope. And we're going to also set the title. And we're going to set some keywords on here. And then once I've set that core properties here, I'm just then asking the XPS package to go ahead and set those back into the root of the document. Oh, what did I do wrong? Thank you very much. So created is a date. Okay, so if I go down here and look at my document, it looks exactly the same. If I go ahead and zoom in down here, hopefully you can see that the title and the metadata down the bottom that I've added is being picked up by the Windows shell. Is that showing? Yeah. That's also picked up by things like SharePoint. We ship a properties handler that you can go and use and program against that from the shell and other things. So that's how you can get metadata into the package itself. Okay, so having done that, the next thing I'm going to go do is just do a quick dive into some digital signatures. And to do this, we just need to, I'm going to do it a slightly different way. I'm going to load this file from disk, and then I'm going to write it back out again as a signed file. So this is taking the XPS file that I created on disk, pulling it in. And so here, again, it's fairly simple. The first thing I'm doing here is getting a signature manager, and that's a co-create instance just to instantiate that COM object. And then I'm loading that package that I specified, my XPS file that I've just created, putting that in from disk. And the first thing I'm going to do is add a signature request. So this is a block within the file that can be interpreted as me saying, hey, I'd like somebody else to sign this document for me for some reason. So I'm going to take that signature request, and I'm going to set the intent, and ask them to confirm that this is indeed rich content. We could discuss later ways they might go about doing that if they're so inclined. And request the person to sign this, and I'm going to request that I sign it, because I'm schizophrenic like that. And the next thing I'm going to do is I'm going to actually go ahead and sign the document. Here I'm using a test certificate, which is our virtual company, Contoso. I'm just loading that in from a file on disk. You'll see it when you look in the debug folder. There's the Contoso certificates are there. And to do that, I'm going to need to go and get the my signature manager. And I need to get the signing options that I want to go ahead and use for this. So the signing options allow me to specify what bits of the document I want to go ahead and sign. So there's different signing policies based on the content that's in there. And so this policy that I want to set on this, because I've added that metadata, I'm also going to ask it to sign the core properties part that includes the metadata as well. And then I'm going to go ahead and ask it to sign my document. I need to give it those signing options. I need to give it the certificate that I loaded from file above. And it will give me back the actual signature that it applies to the file, which I'm not going to use in this example. And then I just ask that manager to go ahead and save that signed file back out to my output file name. So if I go ahead and run this guy, what am I doing today? I think that's what I'm doing today. No. This is why I need my crib sheet. Thank you. I'm glad I asked people to call out when they saw things in the audience. Okay, so here I've got my not blank and my not blank signed. And if I go in and run this guy here, I can go ahead. This time it's got signatures. I can view the signatures. There's the Contoso signature. It's marked as questionable because I haven't plugged this into the network to go and authenticate that root authority on this machine. And here's my request that it's asking for. And here's the thing it asked me to confirm that this is rich content. So I can go ahead and sign this document and then I can send it back and confirm. And then you can use that same certificate API to go and verify that it has been signed and who signed it and get that information back. Okay, so how are we done on time? Good. Time for one last thing, hopefully. So the other thing that I just wanted to do was just show you quickly one of the things that we have within the markup in terms of how you can navigate around that and load that in and then programmatically go and pull things out of the document. So what I'm going to do here is just get rid of that for now. And I'm going to go back into our little function that writes page content. And after drawing all the stuff that I've drawn, I'm just going to go ahead and add a couple of extra text fields. And this first one is just as you've seen before, adding some text called ID. This second one is adding a number, and then it's passing this other string here, order ID. And if I go in and look at what we're doing with that, I said I'd come back to this bit. But here, what I'm saying is, if we specified that, then on that glyphs element that we're adding to the visual tree, then go ahead and set the name attribute for that glyphs element with that tag. So if you're doing hyperlinks, this is how you can set a name destination that you can go target your hyperlink at. Today I'm going to do something a little bit different just to show you how we go about loading up a visual tree. And so to do that, what we're going to do is just take my file that I had on disk, this not blank XPS file, take that same string that I specified for my attribute name when I wrote out the glyphs. And what I'm going to do here in this function is the first thing I'm going to do is here I'm going to load an XPS file from file. So create that package from file. So now I've got a file on disk, I'm bringing it in, instantiating a visual tree, all the objects on that tree. And then I'm going to walk down that hierarchy here of my document sequence, my documents, and I'm going to go and get the first page within that sequence. And then once I've got that page, I'm going to go and have a look and see if I can find that name text that's got that ID tagged on it. And if I find it, I'm going to print it out here. And all this little function here does is it goes through the visual tree and it gets the collection of visuals and it loops through those visuals looking for glyphs elements. And if it finds a glyphs element, it goes ahead and checks whether or not that has that name attribute that's a match. The other thing that we go on and do down here is we check for a canvas. The reason we do that is canvas is a grouping element, so if we hit one of those, we want to recurse back into and go look and see what's inside the content of that. So if I go ahead and run this guy, here's my result, and it's got my order ID has come up as 0010210. If I go look at the file on disk, I can see that that's up here in the corner is the same order ID. So that's the one that I wrote into the document, and I programmatically loaded that all up, pulled that back out, and showed that in the console. Okay, so to sum up the key takeaways from us. First of all, that in Windows 7 we've introduced a new API surface to make it much easier for Win32 developers to work with electronic paper in the XPS format. Win32 is no longer a second-class citizen when it comes to this particular part of the ecosystem. The way that we've done that provides a common layer whether or not you're physically printing or virtually printing. A big trend that we're seeing is increasingly our customers and our development partners are using that print connection point to do more than just physical printing. And that's very important that from the app development point of view, you have the mechanism that you can be abstracted from what's happening downstream from your application. Whether or not it's physical paper or electronic paper doesn't matter if you go down this route. This is an API surface that also gives you print support if you're looking to develop on top of direct 2D and direct write. There's a lot of interoperability capabilities between those APIs. The best place to go and see that is the DirectX hands-on lab. And as I pointed out as we went through, there's also great interop for things like WCS and WIC work very well with this API surface. If you're still very, very invested in GDI and you want to take advantage of the XPS print path in a very limited way, you can use a mechanism that we have in the print driver called MXDC escape. That allows you to inject XML markup directly into the print stream, but you have to take responsibility for that, and the escape is at the page level. So if you have an application where sometimes you want to output an image on a whole page and not do lots of other things, that might be a good way of going, but it only works in certain scenarios. If you're on Windows 7, the recommended route forward for us is to take advantage of the new XPS APIs from Win32. If you're using .NET, we recommend that you go and use the same capabilities that are in .NET 3 and later. They give you access to the print path in the same way, a very similar set of support. In some cases, some very edge cases, you might want to consider wrapping the Windows 7 Win32 APIs. For example, if you're doing a lot of stuff with WinForms and you don't want to move completely to WPF, that might be a reason. We don't think it's compelling enough for us to have wrapped those APIs ourselves. We think the best way is to go with WPF. And just a final comment, those APIs are in the bits today. Feel free to go and play with them. I have a resources slide with questions, with other places to go for information. Please remember to fill in the session evals. It helps us plan not just future versions of this event, but other events as well that are coming up in the near future. And I know a lot of people give those a lot of attention. I'll leave this up on the screen so people can look at this. And if anyone's got any questions, I finished a minute late, so I'm happy to take questions for the next 13 minutes and 30 seconds or whatever it is. And thank you very much for coming to PDC. We really appreciate you doing that. Okay, there's mics there and there, which I don't know if we're recording questions, but at least everyone else in the room can hear.
Hi.
Hi.
Nice presentation. Thank you very much. I have a few questions. Number one is, when you do that XPF document, is that a compound document? Do you render that the JPEG file inside, rasterized inside your document, or is still outside?
It's all inside the document.
All inside the
everything is, yeah, when I opened it up, that was just to show everyone here that they could
so
open
it's
up.
not a compound document. It's all inside the XPF.
It's all inside an XPS
Oh, okay.
file, yes.
And number two is, you say you support the color like RGB, CMYK.
Yep.
Do you support Pantone or the LAB?
We don't support Pantone named colors directly, but we do support named colors, so you can specify those. And we support sCRGB, so you can map an LAB color into sCRGB.
Okay, no spark color. And can I convert the XPF from some other document, or can I convert it into other type of document?
So
is that conversion possible?
It's possible. Microsoft doesn't provide conversion tools for XPS, but there's a number of third parties already that do that. If you look at the Microsoft.com WAC XPS, there's a technology showcase there where a number of third parties have tools and things there.
That I can do conversion from and into. And my last question is, this is API only for Windows 7, not for XP or other platforms?
This is only Windows 7.
Okay.
If you have feedback on that, we'd love to understand scenarios and use cases and those kinds of things. And there's a mail address, xpsinfo@microsoft.com. Please send that to us.
Okay, thank you very much.
Thank you. Can we go other end? Is there?
Hi there. Yeah. Is print schema still part of XPS or completely different specification now?
So print schema has always been a separate spec. If you go to Microsoft.com WAC XPS, there's separate documents for XPS and for print schema. So it's documented separately.
So completely different specification?
Yes. Yeah.
Hi. I wrote an app that converts the XAML flow document to XPS, and it worked great until you guys released 3.5 SP1.
Okay.
And then it broke on the server. It works on the client, on the desktop, but it doesn't work on the server as a Windows service.
Okay. First of all, we apologize. Secondly, if you've got a business card or something, I'll follow up with you. I'll get the WPF guys involved, and we can figure out what we did.
All right.
Okay. Thank you.
Hi again. So I'm asking again about backporting to Vista. So we've got a commitment from the Direct 2D guys that they were going to backport to Vista. So again, just to reiterate how important it is for us to, if we want to do native output to XPS through your API, but if you're going to limit it just to Windows 7, then it's not going to be worth our while doing to this point.
Okay, so I think on that we understand the down level and deployment requests. I would ask that please send us a mail, give me a business card so we can follow up on specifics, because for us it's very, very expensive to do it. So we really need to understand the value that we're adding to the ecosystem as part of doing that. And
so the commitment to port the Direct 2D, so do they not share most of the stuff, or?
We have different dependency stacks.
Okay.
So for example, the particular difficulty that we have on the XPS side is around the crypt support that we need in the stack for digital signature support.
Okay.
And those kinds of things, and that's not something that D2D would have a dependency on.
Okay, got another question about memory. I noticed that through your API, you flush everything at the end of the document. Do you do any streaming of stuff so we don't come memory bound if we want to output a really large document?
Yeah, you can do that. You have control over that within the API. So you don't have to, the way that I've done it here is kind of a very crude, simple way just to give you a view of the API. But you have control over when you write certain things out to the disk.
Is that also the inverse of that correct? So obviously you've written a parser so you can read it in. Do you have to read the whole file into memory, or can I just interrogate certain sections of the XPS without having to load, say, all the images?
So when you're pulling stuff in, there's two levels that you can pull stuff in at. You can do that at the OPC level, where you have very, very fine-grained control over bringing those parts in. Or you can do it at the XPS level, and then you're reliant on us doing lazy instantiation based on when you ask for stuff coming in. Okay?
Yeah, that's great. Oh, sorry, one more question.
Sure.
We do wide format printing, and we often create huge files. So that's bigger than 2 gigabytes. Do you support that?
So bigger than
2 gigabytes.
I don't know. I believe we do, but I'd have to check on that.
Okay.
So if you've got a card or something, I'll follow up.
Excellent.
Okay, thank you.
Okay, quick question. First, the vector APIs, one of those documents up there would explain what you can and cannot do. You only showed a little bit, like just little lines and things like that.
Yeah, so if you're familiar with WPF and XAML, we're a parsimonious subset of that. So you can represent anything that you could represent in XAML, for example, in WPF. But if there's more than one way of doing it, we try in XPS only to restrict you down to a single thing.
So is that documented?
So that's documented in two places. If you go to the Windows SDK that you have on the bits, you can see there exactly what you can do. The actual specification for XPS is documented in a 400-plus page document.
Yeah.
You can go grab that from the top XPS link, and that has the whole graphics model in there.
Okay.
And you'll see that the two are very closely related, so we try and keep terminology the same between them.
Okay, so jumping on a different track, in Windows 7, will the user experience for printers be different? I mean, what's this going to look like? Are they still going to have the same print drivers? And
So we're not changing the driver model or anything. We've done a lot of work in Windows 7 to improve performance and compatibility around the transition from non-XPS to XPS. This is part of that work. There's a lot of other stuff that we've done under the covers to ease that. But from a user point of view, our objective is that there isn't going to be any impact from doing this kind of stuff. If somebody has an application that supports the new APIs and a device that supports the new format, then they get an improved experience. But if they don't, or they have one and not the other, then in Windows 7 we're doing conversion on the fly between the two. And we've worked very hard to make sure there's not a performance hit for somebody doing that. But
must be late in the week. I'm not kidding. Well, I mean, if you have a printer out there going through XPS to get to a printer, is there going to be an XPS printer driver, or is it going to be the device printer driver that underneath the?
So right now there's already devices out there that are XPS printer drivers.
Right.
And so if the driver says, hey, I'm an XPS driver,
okay,
you can have XPS all the way down the wire into the embedded controller in the device.
Okay.
If the driver says to us, I've never heard of XPS, I'm still a GDI-based driver, then the print subsystem does all the conversion for you.
And I assume the application can make the same query to determine whether it should be sending GDI or...
The application can, but the great thing about Windows 7 is you don't have to anymore. You can just always send XPS on Windows 7, and leave it to the subsystem to do the conversion if it needs to go back to GDI.
Okay, that's where I get back to that API, because not everything is backwardly compatible, or is, I mean, bitmap brushes, I didn't see all those things. I don't know if all those things. Everything from GDI is in this?
No, so for example, if you have, so are you asking, can you represent every GDI construct in XPS?
Right.
Yeah.
Okay. All right.
You were first. Okay. My question is, are there plans to make XPS placeable in Microsoft Word so that I can create an XPS document and place it in other documents?
So I'm fortunate in that I don't know any of the Word Office plans, so I can't answer that.
That was my question too.
Okay, again, I can ask them and see what they say.
Okay.
Okay?
What does Adobe say about all this?
I don't know. You'd have to ask Adobe. From our point of view, we can see them as different formats. And if you look at what we're doing in Office, for example, we support both PDF and XPS. We think there's great times to use XPS. We think there's great times to go use PDF as well. So we'd encourage people to look at the scenario and what they're doing and choose the right format. Okay?
Okay, one more question.
All right, sorry.
Sorry. You talked about you've got a converter to go from XPS back to GDI if the print manufacturers haven't bothered to write an XPS driver. Can you give us some details about how full implementation that is? So, for instance, when you're using transparency, are you just flattening to raster, or are you doing a complex flatten with clipping areas and overlapping operators?
So the quick answer is it depends. We had a conversion module in the .NET code in WPF that did a very advanced conversion where we're simulating with GDI some of the more advanced things in XPS. And when we looked at that in detail, we found that a lot of things that we intuitively thought would be beneficial for that conversion by being smarter actually were giving us performance and quality hits that we weren't expecting. So in the conversion path that we've done in the print subsystem in Windows 7, we've taken advantage of what we learned from doing that conversion in the managed code 2 years ago and have adapted it.
Okay, so for instance, if you use transparency, in your example, would it flatten all this stuff under the transparency region, or what do you tend to do?
Well, it
give up and rasterize the whole thing? Or?
It depends, and it's probably not appropriate for me to go into all the details of the way we do that. Okay. We have various ways that we do it. We've tuned that between .NET and Windows 7. I probably can't say more than that about the ways that we're doing that kind of stuff.
But
if you've got some specific reason why knowing that would be important for your application.
It's the expected sort of quality, as in whether we currently flatten our own data.
Okay.
So whether we can give up on that and we can trust your output.
So our intention is that if you have a XPS-aware application and you're going to a non-XPS-aware device, you might get a small performance hit, but you won't get a quality hit because we'll do the work to make sure it's a high-quality conversion. And the other way around, if you've got a non-XPS application, you're printing to an XPS device, again, we've focused very much on making sure that there isn't a quality hit. And in Windows 7, we've made sure there isn't a performance hit either, because we want to encourage people to go that way and transition onto the newer API surfaces rather than staying on the older stuff.
Okay.
Okay. I'm going to hang around for a bit, but thank you very much for coming and being at PDC. Thank you.